So today we'll be discussing on the numerical differentiations, and to do so we'll be starting from our class 12 knowledge, from our higher secondary knowledge, that we know how you can write a differentiation, that limit part, that calculus, very beginning of the calculus, remember that. So let's consider, I'll be considering that dy dx. What does this mean actually? So let's consider the first derivative from your school mathematics, and let we are writing f which belongs to a and b, or f from a and b in real space. So f is a function, this function belongs to a and b, or is from a and b interval, and is from the real space. Okay, then you can write the derivative of f. You can write derivative, write this down, the derivative of f is equals to, or say f dash a comma b, which also in the real space. Okay, so you can write f dash c equals to limit h tends to 0 fc plus h minus fc divided by h. So for all case c belongs to a comma b. You remember those, right? So this thing you remember. This formula you remember from your class 12 or from your higher secondary calculus. Okay, so what does geometrically this mean? So geometrically f dash c basically gives you the idea of the slope of tangent of the curve. Okay, so it is called the tangent of the curve at x equals to c. Got it? This thing you remember from your school. And another thing here I will discuss, that the Taylor series. So let's talk about the Taylor series. If x plus h, this is also well known to you, I think, fx plus h by 1 factorial f dash x. What do you mean by factorial? So what is n factorial? Anyone? Do you know what is n? Yes? And so on, you will be doing that up to 3 to 1, 3 to 1, 3, 2 and 1. Okay, now so if x plus h by 1 factorial f dash x, this well known formula is square by 2 factorial f double dash x. Okay, plus other terms I am writing as a o h. So make some design in the o so that it shows you the other terms. So, or simply write the o. So o means the higher order terms I am considering, or I am taking approximation. Sometimes we neglect this term. Okay, so o is the higher order terms, and this term is also give you the truncation error. Okay, so few things how we'll do this class, that for today's class I will miss intentionally some things. I will not be telling some things about this numerical differentiation and all. In the later class I will cover that, because if I अभी अगर बोल देता हूँ तो you will get confused. So few things I'll be missing that intentionally. Okay, so for the first derivative, what we can do? So for the first derivative, we have, suppose the value of the function at xi and xi plus 1 are f xi, okay, f suffix xi and f xi plus 1. Okay, so f dashed xi can be written as f xi plus 1 minus f xi. Remember, fx in the suffix you have I plus 1, okay, divided by, it's a simple one, that xi plus 1 minus xi. So what they are saying, that if you have, suppose, xi and xi plus 1, then the value of the function value, or the y equals to fx, consider. So y value will be at xi will be a function of xi, and xi plus 1 will be xi plus 1. The difference between these two functions, y2 minus 1 by x2 minus x1, from your last class you remember that, okay. So that's give you the slope, and that slope means is f dash xi, that means dy dx. Okay, so this is called the forward differential formula. So far what we know from our schools, that was the forward differential formula, okay, or in short FD. Let me show you. Okay, so suppose the value of the function as xi and xi dash are fxi and fxi plus 1 respectively. So f dash xi equals to fxi plus 1 minus fxi, xi plus 1 minus xi, and this one. And what will be the backward difference formula? If you do fxi minus xi minus 1, means y1 minus y2 you are doing, then you have to do x1 minus x2. That's called the backward difference formula. Write this down: forward difference formula, backward difference formula. These are not so much important for this course. The point of discussing this, that I want to reach, or I am to discuss the Newton backward and forward interpolation formula. And for that you need to know the difference. So what is backward difference, what is forward difference, and what is central difference, and when we should talk about these differences, and when we should consider the interpolations, Newton forward interpolation or backward interpolation or Stirling interpolation. Now for the central difference formula, we have f dash x fxi plus 1 minus fxi minus 1, xi plus 1 minus xi minus 1. So write this down: central difference. That's the formula for central difference. Okay, so in short we'll be writing FD, BD and CD, and it basically based on the straight line interpolation. Now you can do the 3-line interpolation, data interpolation also. So consider 3 points. What will be the 3 points? So the 3 points are, let's say, xi minus 2, okay, xi minus 1, middle one is the xi, where you will be calculating the derivative at this point, xi plus 1 and xi plus 2. So by doing so you will have the 3-point forward difference, backward difference, and you also have the center difference. Okay, so write this down. So this data point must be evenly spaced. Spacing called the step size is 8. I'll come back to this evenly spaced and what will happen and what you have to do if these are not evenly spaced. So that will be discussed later. Just write this down first. Then we'll be doing a very small problem, and then we'll be done with this. Yes, this one. if you are doing y1 minus y2, I am taking 2 points, I and I minus 1. If I'm spelling this out, then it will take it will be confusing. So that's why I'm talking about that y1 minus y2 divided by x1 minus x2. Okay, or sorry, y1 minus y2, not y1 minus y0 divided by x1 minus x0. That will be your backward difference formula. See here. So for the backward difference, you'll be considering this point and this point. Now this is the formula for the central difference. Now for the 3 data point interpolation, you have these data points must be evenly spaced, and the spacing called the step size. So 3 point forward difference you can write this way. Write this down. Now for the backward, same principle will be applied, same thing will be applied. Test x equal to 3f xi minus 4f xi minus 1 f xi minus 2. And in this chapter, few things you have to remember, okay, like the Newton's interpolation formulas and these 3-point FD formulas. Now the question is from where you are getting these 3-point formula. Okay, so let me give you a brief idea. I'm not much interested in discussing this, but let me give you a hint. Okay, so what you know so far, that f dash xi equals to your f xi plus 1 minus fxi by xi plus 1 minus xi, right? So I'm writing is this way, f2, sorry, it can be written as f1 okay, so it can be written as, let's say I'm writing in a short form, otherwise it will take much time, f2 minus f1 x2 minus x1. Okay, now for the 3-point video, what you will have to do, you have to find out the f dash xy, and you will be considering 3 points. Okay, I plus 1, I minus 1, and I. Okay, so that point can be written as, the difference is, what is will be the difference, or it can be written as 1 by x2 minus x0. Okay, remember x0, this is x minus 1, this is the x minus 2, this is x1, this is x2. Okay, so x2 minus x0, f2 minus f1 by x2 minus x0 minus f1 minus f0 divided by x1 minus x0. from this derivation you will have that formula, like this formula you will be having from after. If you simplify that equation, then you will have this formula. Now for the 3-point backward, this is the formula. So for the 3-point backward difference, this is the formula. Write this down. Then we'll be solving one problem. Let's complete let's wrap it up very fast. Then we'll go to the main topic, that's Newton forward interpolation formula. Are you done up to this? Okay, so now write this down. Estimate, there is an example or there is an exercise that estimate the forward difference, backward difference and central difference using these data points x0, y0, x1, y1, x2, y2 and up to x4, y4. So what would be the forward difference, what would be the backward difference, what would be the central difference at x2 point, they were asking. So at x2 point, what will be the forward difference, what will be the backward difference? Write this down. Okay, for the 3-point FD, 3-point BT, this will be the result. Write this down up to this. Are you done? Oh, okay. Now let's discuss about numerical differentiation, and for that let's consider now from this point onwards, be serious because this is very important. These topics are very important. Okay, the previous topic I have discussed or previous calculations I did, that was kind of a warm up. So this is very important, you have to understand it very carefully. Yes, I will not include all the derivations, but I will include some key points and key formulas from or using which you can get your result. So let's consider a set of equations like xi comma yi, where I is 1, 2, 3. That means it can be x1 comma y1 or x2. The set of the equation will be a set of the data points, not the equation, x2 y2, x3 y3 and so on. If I write in a tabular form that x1 is giving you the value of y1, x2 is giving you the value y2 and so on. Okay, now the spacing between x1 and x2, let's say h. for the sake of simplicity, let's say it's a h1, and for x2 and x3 is h2. Now if xi are equispaced, then what we will do? If xi is equispaced, that means h1 equals to h2 equals to h3 equals to h dot equals to h. That means the difference between x1 and x2 point are equally spaced. Suppose this is 1, so this should be 2, this should be 3. The h value is h equals to 1 here from this example. So if these things happen, then only we can use two things. We can either do the Newton's forward interpolation. We can do two things. We can do Newton's forward interpolation, or second one would be Newton's backward interpolation formula. Okay, if this is not equals to h, so h1 not equals to h2 not equals to h3, then what will happen? Then there are two methods to solve, and these two methods are your Newton's divided difference, is called Newton's divided difference, okay, and Lagrange polynomial. Lagrange is there, Bessel's is there, Lagrange polynomials, and Newton's divided difference if h is not equispaced. Write this down. So, but this thing will not be considering in your course. I'll be only discussing this Newton forward interpolation and Newton backward interpolation. Now, what do you mean by Newton's forward interpolation and what do you mean by Newton backwards interpolation? Let's consider a function. Let's consider a function y equals to fx, okay, and fx0 equals to f0. I'm writing to simplify my writing, or to simplify my writing style. I'm simply writing that f a function of x0 equals to f0, okay. So again, and one more thing, the delta fx equals to fx plus h minus fx, and I have considered h means step size, that is equispaced, okay. So delta fx is giving you the value that fx plus h minus fx, okay. This is called the del operator, or in this case it's also called the forward operator. And why these Newton's forward and backward interpolations are very important? One thing, let me tell you that on the other day we were discussing about the modeling, how we generally do the geophysical modeling or geological modeling. In that modeling, I have also mentioned that finite difference modeling. Okay, so in finite difference modeling, there are several modifications people are using nowadays, but the basic or the fundamentals are coming from this Newton forward formula. Newton's forward or backward interpolation formula. So that's the basic, the fundamental sense is the same. So I'll not be saying that on the basis of these we are making the modeling technique. That will be totally wrong. But the basic, the ABCD of that modeling is coming from that, from this Newton's forward interpolation or Newton's backward interpolation. The sense is coming from this. So these are the, you can say these are the foundation, these are the basics of any modeling technique. You have to understand the mathematical senses will be almost same. Just like we are doing here, that will be done in the divided difference or in the forward finite difference technique also. The sciences are the same, so that is very important for us to know. Okay. Now, what we know, the delta fx equals to fx plus h minus fx. So if I consider f2 and f1, delta f will be f2 minus f1. Is it clear to everyone? Now I'm taking that new function, the order x1. I'm taking x1. That's the adjacent to x0. So x0, x1 are there. x0 is our initial point. and how to estimate x0 I'll be discussing, and where to take the x0, and if x0 is given, then x0 is generally given. So in your questions you will see that find this derivative, numerical derivative, using forward difference formula, forward Newton's forward interpolation formula at point 1 or at point 1.2. So that will be your x0. And what to do if your x0 happens to be far away from the beginning. So that thing will be discussed in the next class. I'm not discussing about x0 now. I'll do a simple math in this class. Then in the backward interpolation, after completing the backward interpolation, I'll be discussing about this in details. So let's consider x1. That could be the your adjacent point. Like this point is x0, this point is your x1. Okay, so x1 is x0 plus h into u. So f equals to, h is the step size, and what is u? U means x1 minus x0 by h. Got it? So to get x1 you have to multiply the u value with h. Okay, so where u is the x1 minus x0 by h. Now suppose your x1 is 4 and x0 is 2 and h is, let's say, equals to 2, so your u is 1. So h will be fixed everywhere. Okay, in this case, so you are having u equals to x1 minus x0 by h. Okay, and h is called step size or the spacing. Now I'll be writing this formula using, so I'll be expand this f x0 plus hu. I'll be expanding this using your Taylor series. So remember the Taylor series, f0 plus u delta f0 plus u minus 1 by 2 factorial delta square f0 plus u minus 1 u minus 2 by 3 factorial delta cube f0 plus u minus 1 u minus 2. Then what will be the value? U minus 3 divided by 4 factorial delta to the 4 f0, where delta fx, you know that delta fx equals to fx plus h minus fx. That's the value of delta fx. And there will be some higher order term that I am neglecting, and due to this neglecting of this term, higher order term, we will have some error that will also be discussed later. So I am writing this fx0 plus h as f. So I am simply writing this value as f, and now what you have to do, you have to derive, take it first derivative of that. So df du, what will be the value? What will be the value of df du? So that will be delta f0 plus 2u minus 1, do that, 2u minus 1 by 2 factorial delta square f0 plus 3u square minus 6u plus 2 divided by 3 factorial del cube f0 plus 4u cube. Derive it, take the derivation of this term with respect to u. You will have 4u cube minus 8u square plus 22u minus 6 by 4 factorial 22. Let me show you. I've written it down. Write this down, the equation number 1, write this down. So from this term you will have delta f0, because du if you take dt u of u equals to 1, so that's why you will have only delta f0. Now this term को अगर तुम derivative लेते हो, if you are taking derivative of this term, then you will have this value. Okay, if you take the derivative of this term, then you will have this value, and so on. So write down this equation number 1 and equation number 2. The higher order terms are neglected, and these higher order terms generally generally develop or generally include some error in the result. So I'm writing in a short manner, like fx0 plus hu. Not every time I don't want to write that fx0 plus hu. So I'm simply writing this term as df. So write this down, df du equals to, we will have this value. Now tell me, what will be the value of du dx? You have the u value. What will be the value of du dx? x0 is constant. So what will be the value of du dx? 1 by h. Also write that down. Now, following your calculus from a school calculus chapter, you know that df dx can be written as df du dot du dx, right? It can be written like that. Okay. So what I will be doing, I'll be calculating the df dx part. How? I know the df du value, I have to add the du dx value. So du dx value I know, df du value I know from this equation. So if I want to calculate df dx, then I will have df dx 1 by h delta f0. What do you mean by df dx? It's basically dy dx. Okay, हम लोग जो कन्वेंशनल dy dx समझते हैं, df dx वही है. फंक्शन को मैं f लिख दिया, that function is equal to y. Okay, so it's basically giving you the dy dx, the simple school mathematics. So we are calculating the dy dx. That means here I am writing the notation is df dx equals to, that's our whole objective to find. So that will be your equation number 2, that df dx equals to 1 by h delta f0 and this value. So 1 by h will be multiplied, and this value will be, you'll be writing this value here. Got it? So this is your equation number 2. And don't forget, these are the factorial. I generally write factorial like this. Some people may write factorial, in some book you will find that they are writing the factorial like this, 2 factorial, or this, sorry, 2 factorial, no, like this, 2 factorial. So this is how I write generally factorials. Write this down, up to equation number 2, and then let me know. Okay, now what will happen if at x equals to x0 or u equals to 0? At x equals to x0, u equals to 0. What will happen at x equals to x0? Means x0 value you are getting. See, these things are seems to be complicated, but the problem, when you will be solving the problem, then you will get the idea. Okay, so first write this down. Now at x equals to x0, the df dx will be this value. It will be simplified like this. You will be putting the putting u equals to 0 in this equation number 2, and you will have this equation. That will be your equation number 3. So equation number 2 and 3 are very important. Now we want to do a double derivative. How we can do a double derivative? We will be doing d2f dx2, where ddx equals to df by dx equals to ddu df by dx du dx. Like this way we can write. So if I modify this term that I am writing, it's a du, then I have to multiply it here as du dx. Okay, if I want to do this, then I will to multiply with this. Now to find out this, what do you have to do? You have to find the ddu. You have to find the du dx. You know the df dx, and you will be taking a derivative on this term. it's a for x equals to x0, not this one, this second. So on this second equation we'll be taking a derivative. So d2f dx2 equals to 1 by h square ddu, and if you do it, okay, then you will get the result like this. So you are simply writing ddu of that term df dx, which we knew from equation 2. We are writing it here, okay. So this is f0, this is u, this is u, this is u, okay. So d2f dx2 will be 1 by h square du dx, and get square f0 plus 6 u minus 6 by 6. We are just simply taking derivative of this term, okay, derivative of this term. So if you take the du of delta f0, what will happen? The du of delta f0, tell me. So if you take suppose du of delta f0, what will happen? It will give you 0. डेरिवेटिव समझ में आ रहा है कि नहीं? So this term you are this term, from this term you are getting that ddu of 2 basically, okay, 2 of ddu of u. So 2 यहाँ पे भी नीचे 2 आ गया, so ये nullify हो जाएगा. You will only have get square f0, and ddu of minus 1 equals to 0. Similarly from this term you are having, so from this term you are having this one, from this one you are having, if any case you got confused, and this will be, if you take the derivative of this will give you 0, right? From this term you are having this. Do that, then you will know. Okay. Now d2f dx2 can be written like this. Now at x equals to x0, u equals to 0. ये अभी समझ में नहीं आएगा, एक प्रॉब्लम करेंगे तो वो समझ में आ जाएगा कि इसका क्या फ़ायदा है. So d2f dx2, and you will have this equation. Write this equation very very carefully. Write this equation. Now similarly for it at x equals to x0, you have u equals to 0. So you will be putting the value u equals to 0, and you will have this result. These two equations you have to remember for your exam purposes. These 5 equations actually. Not the 5, these 4 equations. Equation number 2 to 5 you have to remember. 2, 3, 4, 5 you have to remember. So I might ask about, or in your examination you will see that you have to do df dx or dy dx, or you have to do d2f dx2. Both the thing you could have to do. So you better remember these equations. Okay, now we'll do a very simple problem. So given cubic polynomial with the following data points. Are you done with this writing up to equation 5, Priyasmita? Okay. Now you have to solve one problem, that given cubic polynomial with following data points, these and these, find df dx and d2f dx2. So it will be d2f dx2. d2f dx2. Okay. And similarly also find df dx and d2f dx2 at x equals to 0.2. So from this exercise, or from after seeing this problem, we can easily identify that x equals to 0 value, you know. Okay, x equals to 0 is given, the value of fx x equals to 0 is given, and here you have to find x equals to 0.2, which is not given. So what does that mean, and which type of equation and which equation it will apply, which equation you will be using for this first case, and which equation you will be using for the second case. I'll discuss that. Just write this down. Okay, I'll be back within a minute, so write this down. Are you done with the writing, class? Okay, now for x equals to 0, where a 0 value we already have, to do so we have to find what values we have to find from this equation. See, the equation contains all the del operators, del f0, del square f0, and what does del means? Del means, del fx means fx plus h minus fx minus f2 minus f1. If I simplify this, then you can write that f2 minus f1 और f3 minus f2. मतलब बाद वाले से तुम पहले वाले को सब डिडक्ट करोगे. ओके, कैसे करते हैं, लेट मी शो यू. There was a specific writing style to find out the delta f, and you have to follow that only, otherwise your okay, for this there is a specific writing style. So first I'll be making a table x, second table will be a y equals to fx, okay. So second table is with fx value or y value, and third table will be about delta f. Fourth table will be delta square f, and fifth table will be delta cube f. Now I'm taking the data points 0, 1 is given, 0, 1, 2, 3, and the values are 5, 6, 3 and 8. Am I right? So what will be the value of delta f? What will be the value of delta f? Delta f value will be, subtracting 5 from this one. So 6 minus 5, it will be 1. Am I right? And you will be writing, there is a specific writing style I have already told you. So you better give spacing between, when you are writing this 0, 1, 2, 3, 5, 6, 3, 8, you better give way spacing in between them, so that you will be writing the difference in between them. So this is the difference value. So this will be your delta f. It's very interesting and very fun way to do it. So now 3 minus 6, it will give you minus 3, and 8 minus 3, it will give you what? Plus 5. It will give you what value? It will give you 5. Now for the get square f, what I will do? what will do? -4. Got it? किसको समझ में नहीं आया बोल सकते हो. And this one will be 8 or +8. 5 minus -3, so that will be minus plus, so 5 plus 3 हो जाएगा, वो 8 हो जाएगा. Now this will give you which value? 8 minus 4, it will give you 12. Now our first problems, what is our first problem? It told you to find the df dx at x equals to 0. Now here x value x equals to 0 is given, and I'll be considering this as x0. Remember the formula 3. Okay, so in that formula I told you x equals to x0 and u equals to, where u equals to 0. X equals to x0 I am considering when u equals to 0. In this case u equals to 0, there is a no, because we know the value here, we know the 0 value here, we have the 0 value with us on or in the data point. So if I am considering this x0, there is no difference, so u will be equals to 0. Okay, so I'll be considering x0 point is which point they ask? X equals to 0. Yes, x0 point will be 0 where u equals to 0. So which formula you will be applying? The formula number 3. Okay, so that formula you will be applying. So df dx x equals to x0. Got it? When you have the value, then you will go for this formula. When you have the value, it didn't have to calculate from that point. So suppose, okay, suppose the spacing is h, this is x0, this is x1, this is x2, and these are given the values. If you have to find any derivative at this point or at this point, if you have to find derivative at this point, then this point will become your x0, and you will be applying this formula. Now if you have to find at this point, then what you will be doing? This will be your x0, this first point will be your x0. Okay, or to confuse nahi karte, let's say this is the point number 1, this is the point number 2, this is point number 3. So the first point will be x0 when if you want to derive this value and which was not given. If the x value is not given, and that value you have to, at that point you have to find out the derivative, then you will be using the equation number 2 related to u. Okay, that's I'm coming to that. Now if you have this value you have x0 and x0 equals to 0, by using so you will be calculating the df dx. Now do that. So df dx equals to 1 by h, what will be delta f0, delta square f0 by 2 plus delta cube f0 by 3. The formula, remember the formula. And why I have written up to delta cube f0? Because after that it's not possible to find out the value of delta. Delta for f is not possible here, so that's why I am taking up to delta cube f0. If delta for f is there, then you have to take up to delta for f. Now if this is x0, there is a way to do it. First you will be marking this like this way. If this is the x0, you will be marking this way, so that you can understand, or I'll suggest you do this by pencil. Okay, so if you do that, then you can understand that what will be the value of delta f, what will be the value of delta square f, what will be the value of delta cube f. What is the value of h? What is the value of h here? What is the value of h? The spacing. What is the value of h? H equals to 1. Yes, so h equals to 1, and delta f0 value from this, ये एक घेरा बना देना जो जिससे तुमको आइडिया लगे कि कौन सा पॉइंट तुम ले रहे हो. ओके, कौन सा पॉइंट के रेस्पेक्ट में तुम क्या कर रहे हो. सो डेल्टा एफ विल बी इक्वल्स टू, यस, डेल्टा एफ इक्वल्स टू डेल्टा एफ0 इक्वल्स टू 1 माइनस डेल्टा स्क्वायर f0 by 2 equals to -4 square by 2. Delta cube is 12 by 3. Okay, delta square, not square, so delta square f0 is -4 by 2, delta cube f0 is 3. Second order difference is your -4, third order difference is 12, right? So it's coming around, tell me 1 minus plus 2 plus 4 is coming around 7, not 6. Yes. Now find me the d2f dx2. Which formula you will be applying? Tell me the equation number. You have written the equation number, right? For x0, for x equals to 0, if you want to derive this formula, or if you want to derive the value of d2f dx2, which equation you will be applying? Which equation? Equation 5? Yes. So that's the simplest equation you will be using. So that equation, to it, 1 by h square del square f0. That equation you will be doing up to del cube f. Okay. And by doing so, you will have what value? Tell me the value here. Yes, the value is coming around minus 16. Now let's solve the second problem. So second problem is all about, we have to find out the derivatives df dx and d2f dx2 at which point x equals to 0.2. Here the x value they were asking in the question is not included in the data. So what I'll do, I'll take one nearest point. So 0 point we know value, this is the value of the x, 1 point value we know, 2 point value we know. So I'll be taking, if I want to find the 0.2, I'll be taking x equals to 0 as your x0. So your x0 will be equals to 0. I'm taking nearest point. Okay, and h is always 1. For this problem, h is 1. Now find me the value of u. What will be the u? Our x is 0.2. So u is equals to x minus x0 by h. So 0.2 minus 0 by h is 1. So u equals to 0.2. Got it? कैसे करना है? Got it? Now u value you know. u का वैल्यू तुमको मालूम चल गया. Now what you have to do, you have to find which formula you will be using for df dx at x equals to 0.2. This is how you will write it, 1 by h, the longest formula you will be using, not the simplest one, delta f0 plus 2 u minus 1 2 factorial delta square f0 plus 3u square minus 6u plus 2 divided by 3 factorial delta cube f0. Delta cube f0, this one. Okay. So using this formula, you will have the result. Put it. Now you know the u value. So this kind of problems are very easy once you fix up your table. Once you get the idea what will be the values of delta f, what will be the values of the orders of the delta f or delta f, delta square f, delta cube f, then you can easily do df dx or d2f dx2. So what will be the value here? Do it. ये सबको समझ में आया? This part, this is from the formula, and where you will be applying this part. You got it right? Plus, okay. Now do it. Df dx equals to x equals to 0.2 1 by h delta f0 to u minus 1 by 2 factorial del square f0 3u square minus 6u plus 2. Do this. Tell me, what is df dx? what is the value you are getting here? कितना आ रहा है? 1036. No. कैसे 1.4 आ रहा है? डेल्टा F0 को भूल गया क्या? नहीं, मैं इसको करके रखा. यस समोनस. नो, इतना गलत कैसे हो रहा है? लेट्स राइट df dx. The formula is 1 by h, then delta f0 plus 2u minus 1 by 2 factorial. You didn't consider the factorial, tell me honestly. Did you consider the factorials? Up to this. So 1 by h, 1 by 1. This will be, let's take another color. 1 plus 2u, 2 into 0.2 minus 1 by 2 factorial is 2 minus 4. Check your calculations. Whatever I am writing, 0.2 square minus 6 into 0.2 plus 2 by 3 factorial means 3 to 1 multiplication होगा, so 6 and it will be multiplied with 12. So this will be the value 1 by 1 equals to 1. I am not writing. This is coming around how much? This is coming around 2 into 0.2, so it will be 0.4 minus 1 by 2 multiplied with 4, okay, plus 3 into 0.2 square minus 6 into, do this first, do this one, do this and let me know. Let me do it ना. So this will be 2. So पहले इसको कैलकुलेट करो और मुझे बताओ कितना आ रहा है. ये 2 आ रहा है, ये 1 आ रहा है क्या? क्या कैलकुलेशन कर रहे हो? Zero point two into 0.2 into 3 minus 0.12 minus 6 into 0.2 minus 1.08 plus 2 0.92 आ रहा है ना, ये into 2 1.84 आ रहा है. ये कैसे 2 आ गया? कौन बता रहा था मुझे? So is coming around 1.84. ओके, सो ये आ गया तुम्हारा 1 और इसका वैल्यू कितना आ रहा है? इसको काट करोगे तो ये 2 आएगा. 1 माइनस 0.4 1 minus 0.4 0.6 into 2 1.2 आ रहा है ना, ये 1.2 और ये आ रहा है 1.84. Am I सही किया कि नहीं? So what's the value here? 4.03 और 04 आएगा ना. यस, 4.04 आएगा. So that will be the result. Yes, who said it before. Okay, now find me the value of d2f dx2 at x equals to 0 to x equals to 0.2. So now find me the value of d2f dx2 at x equals to 0.2. मैं इसको डिलीट कर दिया. So d2f dx2 equals to 1 by h square, and the value will be getting, so what will be the value at x equals to 0.2. so it will be delta square f0 plus 6u minus 6 by 6 delta cube f0. I'm putting the value here of 3 factorial, and the second term, third term you will be writing which one, minus 13.6. so this will be your answer. So by this way you can get the values, any values within any cubic polynomial data set. Okay.